Alright guys, in this example we'd like to derive a formula, two formulas, one for the surface area and one for the volume of a right regular pentagonal prism. It's quite a name. So the idea here is that the base of this prism is a regular pentagon, and this right here is the base, right? This is a cutout of the base. And then the right regular, the word right here means that the pentagon itself is built out of a right angle from base to base, right? So there is one thing, if we're going to find these formulas, then there's one thing missing from this picture. We are given that the apothem here is length A. We can use that to calculate everything else that we need for the pentagon. But the other thing that we do need, though, is we need to know the height of this prism here. So we need to know h. H is going to be a variable, right? So it's going to be independent. It's independent of A. Everything else for the pentagon, though, can be computed in terms of A. Now, remember, for a regular quadrilateral, but especially a regular pentagon in this case, there's a formula for the area of the base. And so we're going to need the area of the base to compute both the surface area and the volume of this entire figure here. So the area of the base is 1/2 times the length of the apothem times the perimeter, P, of this entire shape. And so if we want to compute the perimeter, we need to use the fact that this is regular, right, to find the side length here. So what I'm going to do is add a couple of lines, and then we'll zoom in and take a closer look. So this right here is going to be a radius, so that's R, the radius of this shape. And then we're going to obviously need this side. And then I'm going to zoom into this. So let's see what we've got here. We've got a right triangle with this leg length A, and what we really want to know is this leg down here. But the question, so then to do that, the question is going to be, what is this angle? So I'll call this angle theta. So at this point we should work out what each angle of the pentagon itself measures. So here we have each angle. By when I say each angle of the pentagon, I mean the angles up here. Remember, the formula is 5, so the number of sides, which is 5, minus 2 times 180 degrees. That's the total angle measure of the entire pentagon, interior angles of the pentagon. And then we divide by the number of angles, so divide by 5. And this will be the measure of each angle of the pentagon itself. So this is going to be 3 times 5 goes into 180, 34 times? 36 times, right? 36 times. So 36 times. And then this is degrees. This means that each angle up here measures 108 degrees. So that's 108 degrees for angles of the pentagon itself. And now, at this point, we want to know what's our angle theta. Because this is a regular pentagon, the radius bisects the angle. So the radius bisects the angle. And what we end up with then is that theta must equal half of 108 degrees. And so that's going to be 49 degrees. So this angle right here is 49 degrees. That means that our side length over here, this is really 1/2 of the side length of our pentagon, right? So we can now use trigonometry. So 1/2 S is now equal to, this is going to involve the tangent, right? So let me actually write this out a little bit better. So the tangent of this angle is the opposite over the adjacent. So the tangent of theta is equal to the opposite A over the adjacent, which is 1/2 S. And then we want to solve for S, right? So we can take this 1/2, we can multiply top and bottom by 2. So multiply by 2 over 2. That'll cancel the half on the bottom. Just doing some algebra tricks here. And then I want to multiply the S over and divide the tangent. So it's like a cross multiply trick. Just swap these two. And what we end up with is that the side length, S, is equal to 2A divided by the tangent of the angle theta. And we know that the angle theta is 49 degrees, right? So this is 2A over the tangent of 49 degrees. And I'm going to leave it like that. So that is our side length S. By the way, that means then that our perimeter is 5 times that, right? So now our perimeter is equal to 5 times the side length, because this is a regular pentagon, so all the sides have length S. Add them all up, there's 5 of them, so we get 5S. And so if perimeter is 5s, then it's going to be equal to 10a over the tangent of 49 degrees. I'm going to leave everything exact until the very end. And that means then that the area of the two pentagons, so the area of the pentagons is, remember, 1/2 times the apothem length times the perimeter, right? So what we end up with here is that it's 1/2 times a times 10a over tangent of 49 degrees. Or what we end up with then is a is equal to, this can cancel, become a 5. So 5a squared, apothem squared, over the tangent of 49 degrees. All right, so that's the area of the bases of these things. Now we need, for the surface area, we need to find the area of a face. So the faces, by the way, have base s, height h, so their area is going to be just s times h. So the area of these faces is going to be s times h. H, remember, is independent, but s is given by this formula that we just found. So this is our s, so we have to get that in there, right? So this is then 2 times a, apothem, times h over the tangent of 49 degrees. And again, we have 5 of these faces, right? So this is for each face. And so then total, we have the total surface area, right? So surface area is equal to 5 times the area of a face. So this is 5 times 2a times h over tangent of 49 degrees, plus 2 times the area of the pentagonal base. So 2 times this 5a squared over tangent of 49 degrees. So it's 2 of the pentagonal faces, the top and the bottom. And we can combine some stuff here because we end up with a 10a over tangent 49 in each one of these terms, right? So let me rewrite this a couple ways. 10a times h over tangent of 49 degrees, plus this becomes 10a squared, but I'm going to write it as a times a, all right, over tangent of 49 degrees. And when you write it this way, you see that you have this common term of 10a over tangent 49 degrees on both of these terms. And so we end up with this formula for the surface area of our regular, or right regular hexagonal prism. Quite a mouthful, right? This ends up being 10 times a over the tangent of 49 degrees times h plus a. All right, so I'm going to leave this as it is because tangent of 49 degrees is not going to be a pretty number. It's going to be a decimal. We're going to have to decide where to round it. So I'm going to leave that exact. And if you ever need to compute this, you can just plug in. And when you plug in at that point, you can plug into your calculator or GeoGebra or whatever you're using, tangent 49 degrees, and you'll get a proper rounding. You don't want to introduce rounding error before it's required, right? So there's the surface area. Now let's go back to the volume. We skipped over that. The volume, remember, of any prism is computed as the base area. So the base area times the height. All right, so it's almost easier. We almost could have done this one first, right? The base area we computed down here to be this. This is our base area, right, of the pentagonal base. And the height is just h. It's just h. All right, so our volume is actually going to be a little bit simpler. It's going to be the following. So volume is going to be, remember, the height is h. This is our base area. So that's going to be 5 times a squared times h over tangent of 49 degrees. This one's in units cubed because the a and the h are where the units come from. This is in units squared because there's only squared terms in each one, right? So this one's in units cubed. Again, if you know the numbers, you can plug in and use the tangent 49 function on whatever calculator device you're using to get the right answer. But here you go, formulas for the surface area and the volume of a right regular pentagonal prism.